Let's go ahead and take a look at this next part. So here we go. We're solving. We're going to solve each equation over this interval. So this is the same thing as what we've been doing, guys. It's the unit circle. Now, if you notice, I have sine 2 theta minus sine theta. These are not like terms. I cannot combine those because the angle for this first term is completely different than the angle from the second term. So what are we going to do? We're going to look at our properties up here. I guess I shouldn't have zoomed out too much. Can I match this? I can. Look, I'm going to continue with my color coding. If you notice, sine 2 theta, now we're working backwards. Watch what happens when we substitute the other side in. So this is going to be 2 sine theta cosine theta minus sine theta equals 0. All right, now I have a little bit more freedom because all of my angle measures are the same. Also, if you notice, both these terms have sine theta. Let's go ahead and factor that out. So we're going to have sine theta factored out. So that's going to leave 2 cosine theta minus 1. All right, I can go ahead and solve for both of these. I know what sine theta of 0 is going to equal. I also know what 2 cosine theta minus 1 equals 0. I know what that's going to be. That's going to be a half. So our answers over here, remember where sine equals 0, that's the ends of the unit circle, the left and the right. So theta is going to equal 0 pi, and then this is a positive 1 over 2, so I know my radians into 3. And cosine is positive at pi over 3, and then 5 pi over 3. So that's going to be the answer to this. And remember, I used that first property there, so I'm just going to continue with my theme of color coding. All right, let's take a look at the next one. So let me kind of undo my paper here because I still would like the angles to be visible. All right, so on this first one, guys, we are having some tangent. We have not talked about tangent yet, so we definitely need to talk about tangent. It's hanging out up here at the front. All right, so tangent 2b equals to tangent b. They almost look like they're going to be the same, but they're not. They have 2 different angles here. So what we're going to do is we're going to replace the left side with the right side. But where there's a theta symbol up here, we're going to use the beta symbol. So here we go, using the property. It is going to be 2 tan beta. That's going to be the top. The bottom is going to be 1 minus tan squared beta. All right, now I'm going to rewrite the right side, which is 2 tan beta. All right, so guys, we are solving an equation. No solving with a fraction. And remember, when it's an equation, we get to change it. So what I'm going to do is I'm going to multiply both sides by this exact denominator. So 1 minus tan squared beta, 1 minus tan squared beta. All right, those get wiped out completely. Over here on the left side, we're going to have 2 tan beta equals 2 tan beta times 1 minus tan squared beta. Okay, look. This is stuck next to parentheses. So this is being multiplied by that. Don't factor it. Let's divide both sides. If you notice, they're the same exact thing. If I divide both sides by this is going to be a 1 over here. Watch. And I get to divide because it's right next to a parenthesis. It's not next to a plus or minus. So I totally get to do this. This is good math. Look, anything divided by itself, that's a 1. All right, let's take a look at what happens now. So 1 equals 1 minus tan squared beta. So move the 1 over. There's a 0. and I'd never solve a negative variable. I am switching sides. Everything's moving. This is going over here. The 0 is going over to the right side. All right, so positive tan squared beta equals 0. Where does tangent equal 0? Remember, there's only two places. It's, again, the left and the right side of the unit circle. So beta is going to equal 0 and pi. That's the angle that's going to give you the answers for that. And I'm going to box it in pink because I highlighted it in pink. No reason to stop now on the color coding. Okay, next one. Cannot combine those, guys. That's a 2 theta. That's a regular theta. Those are not like angles. So since this is in cosine, I kind of want to leave it in terms of cosine. So I think that I'm going to use this property that I highlighted in orange. So look, I'm going to replace cosine 2 theta with this. So it's going to be 2 cosine squared theta minus 1. Now write the rest of the problem. Minus cosine theta equals 2. Okay, let's go ahead and clean up things. You have an exponent, which means it needs to be set equal to 0. You need to move this 2 over. I'm going to move the 2 over and write it all in order at the same time. So we're going to be looking at 2 cosine squared theta minus cosine theta minus 3 equals 0. Pretty sure this is factorable. -6, and I want it to be a -1. What are factors that multiply to a -6 but combine to be a -1? That's going to be a -3 and a +2. Now remember, I slide and divide. So this is going to factor into 2 cosine theta minus 3. And then this is going to be cosine theta plus 1. All right. Now, when you set these equal to 0 and solve, you're going to get an extraneous answer. Let me show you. So look, when you solve for here, you're going to get a +3/2. And a +3/2 is going to be outside our domain. So that's not going to have an answer. That factor is not going to have an answer. But this one will. Let's look at this one. So this is going to be cosine theta equals a -1. And we sure do have that on the unit circle. Remember, that's over on the left of the unit circle. So we know the answer for this is going to be pi. Now remember, I used my little one that I highlighted in orange. And that's how we're going to solve those equations.